polyprotic acid is an acid that is capable of losing more than one hydrogen or one proton during a titration. As you can see, the acid loses hydrogens in steps. It doesn't go from the fully protonated form all the way down to the deprotonated form. There to the right is just the equilibrium constants for each step. And then here we have a titration curve of a diprotic acid, di meaning that there's 2 hydrogens to be lost during the titration. At point A, there hasn't been any hydroxide ions added yet, so we have only the fully protonated form of the acid. At point C, we have our first equivalence point, which means that enough hydroxide anions have been added to completely convert H2A to HA-. So then when you take the volume of hydroxide that you needed to reach the first equivalence point and divide it by 2, we reach point B, which is around the buffer region. It's the half equivalence point. And at that point, pH is equal to pKa because the concentration of H2A and the concentration of HA- are the same. So this log would be equal to 0 and pH would be equal to pKa. Then we can jump up to point E. This is the equivalence point 2, where enough hydroxide ions were added to convert this HA- into A2-. Then again, if we divide the volume it took to go from HA- to A2-, we would end up at point D, which is the buffer region, and again at that point pH is equal to pKa because of this Henderson-Hasselbalch equation. And these equations are called the fractional composition equations, and they give the fraction of each species of either acid or base at a given pH. And using these equations, we can determine the composition just by using the pH. In these equations, we have the concentration of hydrogen and the equilibrium constants, so we can use these equations to determine these numbers, and we just plug it in for whatever the pKa's are for each step and the pH that we are looking for the composition to find the composition of these acid forms. And then this little chart below just shows us that as we increase in pH, the composition of what we start with is the composition of H2A. As we get to this first equivalence point where pH equals pKa, the concentration of HA- increases and that one decreases to 0. As we increase to the second equivalence point where pH equals pKa, the fully deprotonated form is the species that's present, and then both of these species head to 0.